Yay!
Yay! Now let's integrate something new that has nothing to do with any kind of a ring. How about that? That's refreshing. Let's talk about integrating a line of charge. We'll do a couple examples of this. So here's a problem where I want to know what the electric field is at a point P, and it's along the line. This line segment has a length L, charged up to plus Q. And I want to know what the electric field is along the line, some distance A away from the end. There's different ways that you can write what that position is, either with respect to the end of the bar or back to the beginning of the bar. You can write it both ways. Anyway, I want to know what the electric field is out there. I think kind of obviously the electric field is going to be going in the X direction only, right? There's not going to be any Y components. So again, we're going to chop this bar up into lots of little bits, dq. Each of those little bits is a different distance away, so we're going to have to integrate. So we know that we're going to have this, the electric field. I'm just going to do the magnitude because I already know that it's going to be in the plus X direction. So the electric field is just going to be the integral of K dq over r squared, right? Again, I'm not doing the over r cubed r vector because I already know it's going in the X direction. So I can just do the magnitude of the electric field. Okay, I want to go, I'm integrating from 0 to L, it looks like. But Q doesn't go from 0 to L, X does. So again, we have to do dq to dx. That's what I want to do. And so it's kind of the same old trick. A little bit of charge compared to the whole charge is like a little bit of length compared to the whole length. How about that? That's not bad. So my electric field is going to be integral 0 to L. I'm going to have kq over L. There's my dq becomes my dx now. I'm going to have my r squared on the bottom. All right, so let's take the k, q, and L outside. I have 0 to L. I've got dx over, okay, that r squared. Okay, what is r? R is this, right? That is that. Just to illustrate. It's the distance from each little bit of charge out to the point I'm interested in. So how would I write that? It looks like I can write it in terms of the things that I already know, right? There's different ways you could do it. Let's say that's going to be let's see, it's L. It's the total distance of the bar. It's L minus the X, where I am, plus A. How about that? So it's going to be L minus X plus A. And that whole thing is squared. Because if I take L, I subtract off where the thing is, X, I'm going to have that extra distance on the bar, and then plus A, the distance from the bar, gets me out to P. That should work. Okay, so let's do this. And now what I'm going to do is say, again, this is U substitution, so U is L minus X plus A, du is minus dx. And I've got that, except for the minus sign. So this is going to be minus aq over L, 0 to L. I'm going to have du, yeah, I've already got the minus sign, du over u squared. Okay, no problem. So that's u to the minus 2. What's the integral of u to the minus 2? It's u to the minus 1 over minus 1. So it's minus 1 over u. Okay, so this is going to be, the minus signs cancel, kq over L times 1 over, now let's plug this back in, L minus X plus A, 0 to L. There we go. So let's see, how about if I aq over L, let's plug in L for X. So that's L minus L, 0 plus A, so that's 1 over A minus 0 for x is just 1 over L plus A. There we go. So there it is. You might, because maybe this is a little, maybe we place the left-hand side of the bar at the origin, and so maybe what you're interested in, some distance away greater than L. So you might say that you're a distance, total distance x away from the center. So if you could, I've seen it written like this, if x is L plus A, in other words, where P is, it's located at coordinate x on the x-axis. That's a distance L plus A away, right? So if that's true, then this would just be written like this. AQ over L. Let's see, that would be 1 over A, 1 over X minus L minus 1 over X. I suppose you could write it like that. Oops. Goodness, that looks terrible. That's a better box. Anyway, you can write it a number of different ways. So one thing that we haven't done yet that we probably still need to do is figure out what the electric field is from a line of charge if you're located not along the axis of the bar. So what if you're located above or below the bar? That's going to be an important case. So that's remaining yet to do.